In this video, we're going to look at the dry type transformer, the hermetic type transformer, and the conservator type transformer. We're now looking at a hermetic liquid immersed transformer. Let's have a spin. We can see on the top that we've got some low voltage bushings. That's these four thick ones here. The reason they are the low voltage bushings, or the reason that you can tell, is because the connections are very large. The reason they're large is because the voltage is low and the current is high. The load tap changer is mounted in this section here, and this type of tap changer is mounted directly within the transformer tank. That's not always the case. Sometimes the transformer will be mounted externally, or perhaps it will have its own compartment within the transformer tank. The disadvantage to having a tap changer directly within the tank is simply that it shares the same insulating liquid as the transformer, and this is the gas actuated relay. The gas actuated relay is contained within this square box. You may also have heard the term Buchholz relay, although the Buchholz relay and the gas actuated relay are slightly different. A gas actuated relay protects against small electrical faults within the transformer and large electrical faults within the transformer. But there is also an interesting component fitted below the conservator, and this is known as a dehydrating breather, sometimes called a silica breather because it uses silica gel. I'll just rotate around the side. You can see that we've got an entire radiator this time. The liquid enters the top of the radiator, it cools down, and then it passes out the bottom. And we'll have natural convection in order that the process continues, and we can cool down the insulating liquid as much as possible. As you can see, this core has 3 limbs, and these 3 limbs indicate to us that this is a 3-phase transformer. The top and the bottom of the transformer core are known as the yoke. Now, the reason that we clamp these very thin laminate sheets together is because we want to reduce the hysteresis and the eddy current losses. So we'll clamp all of the metal sheets together to form a limb, and then we'll clamp the metal sheet pieces together to form the yokes, that is to say the top and the bottom of the transformer core.